Good afternoon, student. Welcome back. Welcome back to Mr. Chen's master class. So last time we started off with 4.5, which is the same as uh, the same as the section of 5.3. So making a graph of sine and cosine, and also the analytic part of the graph. So one of the error that I made last time is 6b right there. So let me go back to that problem. Okay, so let me just snip that one and then put into the new page for the slide. So last time what I did there, I put in like a different range, but this one, okay, I put in like 0 to infinity, but the range for this one, it's actually something else, okay? So let me show you that right here. So we don't need to do it with the decimal, we don't need to do it with any calculator, we just want to interpret it from the graph right here. Okay, so you'll see that in a minute. So for the domain, again, this one, it's all about the matter of the value of x. Again, for cosine of x, there's no restriction. So that one right there, so basically we can just conclude that it's just from negative infinity to infinity for the domain. Again, if there's no restriction involved. So you might be wondering, wait a minute, it's in the denominator, but right here it's a power. So it doesn't really matter. So the inner function or the subfunction is considered an exponential. So for that power, so it could be any real number. But what about the range? How do we determine the range? So the range, there's so many factors involved right here. So besides the exponent, so we also do have the denominator. Okay, so 3, and also the numerator, 1 right here. Well, let's find out. So for the exponential functions, so what we can do, one thing that we can include that for cosine of x. So the range of cosine of x is always bounded right between -1 to 1. Okay, it's always being bounded from -1 to 1. So let's say that we do have a very small number, so -1. So then that'd be 3 plus 2 to the power of -1. And that number right here, so this one would be considered 1 over 3 plus 1/2. Okay, so if that's 1 over the quantity of 3 plus 1/2, then that'd be 1 over 3 and 1/2, so then that would be considered 7 over 2. So that number would be considered 2 over 7. Okay? And also, let's say that cosine of x could be 1, then that would be considered 1 over 3 plus 2. And that number would be considered 1/5. And you may notice that, the smallest value for this one, it's 2 over 7, and the maximum number right here would be considered 1/5 for the range. Okay, so 2 over 7 to 1/5. And then that'll be the range for this one. So what I did there last time, I put in like infinity and saying that this one is getting close to 0. But that's not the way to interpret it, okay? It's about the matter of fact, cosine of x, the range. And then we put in those small number and the biggest number to find out the minimum and the maximum. Okay, so now let's see what else that we have. Oh, another thing is that it's the 0. So let's say that cosine of x could be 0. So let's say that you plug in a number, cosine of x equals 0, then that'd be 2 to the power of 0, then that'd be 1. So 1 over 3 plus 2 to the first power, 3 to the 0 power. So then that'd be 1 over 3 plus 1, then that'd be 1/4. So 1/4 somehow is actually greater than 1/5. So this one I would say that it's being bounded from 2 over 7 to 1/4. So basically this one you want to test out all those positions. -1, the smallest range for that cosine, and the biggest range for that cosine. And also the midpoint right in between that range. Okay, so you find out that it's being bounded from 2 over 7 to 1/4. So this one, it's a little bit tricky. Okay, so now let's see what else that we have for the rest of the problem here. So a point of the graph of y equals a cosine of 3x plus k plus 2, so the function itself is pi over 2. If the given function is stretched vertically by the factor of 6 and compressed horizontally by a factor of 1/2. So what are the new coordinates of point pi, comma 2? Okay, so this one is one of the interesting questions. Okay, so that sounds a little bit vague. There's so many things involved for this one here. So according to the function itself, so this one it shows like a non-factor ultimate form of cosine. Okay, so let me put it right here. So if this one shows like a non-factor ultimate form, okay, so one thing that we want to interpret here is that the original function itself, so we got pi, and then the value for y, then that'd be 2. So basically what this one is saying that if you plug in pi, so we end up with 2. So 2 equals a cosine of 3 pi plus k plus 2. So in order to have that happen, so that means 2 minus 2 would be 0. So 0 equals a cosine of 3 pi plus k. But one thing that we notice that a cannot be 0, so the only thing could be 0, then that would be cosine of 3 pi plus k equals 0. So 3 pi plus k, cosine of 3 pi plus k equals 0, so that means this whole constant. Then that means the result would be considered either pi over 2 or 3 pi over 2. So it could be like any kind of multiples of pi over 2. Because at those positions, so that means we can solve for k. So k could be either pi over 2 minus 3 pi or 3 pi over 2 minus 3 pi, all that. It's all about the multiples of, the solution of pi over 2. So in order to find out the new xy coordinates, well, this one is a plural, so that means more than one solution. So we need to come up with the transformation. So this one is saying that it's stretched vertically by the factor of 6. So that means right here, right in front of that cosine, we need to multiply by 6. And then it's compressed horizontally by the factor of 1/2. Compressed horizontally by the factor of 1/2. So in other words, that means we need to multiply this one by 2. Okay? The reciprocal. So we need to multiply that b by 2. And then it comes up with the new coordinate. Okay, so let's see. So what we found, so it's y equals 6a. And then cosine of, well, for the 2 you want to distribute, then that would be 6x plus 2k. And then plus 2. So that means for the new value of pi, then that would be considered 6 pi plus 2k. Okay, so 6 pi plus 2k for the new x coordinate. Again, we don't know what k is. And then what about for the y value? The y value is based on the fact of 6a and 2. So the smallest number for this one, it's negative 6a, because that's a cosine, so it's from negative 6a to positive 6a. But somehow the vertical translation is plus 2. So negative 6a plus 2, it's less than or equal to y. And then y, it's less than or equal to positive 6a plus 2. Again, there's no need to solve for k and a. So this one, those are just a factor, the possible factor for the x value and the y values. Okay, so this one, it shows the range for the y value, and this one, it shows all the possible x value. So for the xy coordinate, so just put it this way. Okay. So now let's see what else that we have for the rest of this. And for number 8, the word problem. So the blood pressure of a person is modeled by the equations P of t. So that equals 110 plus 20 times sine of 150 pi t since 12 a.m. So the initial time. So it started off at noon. In the midnight. And then blood pressure is measured in millimeter of mercury, the unit. And the time is measured in minute. Okay. So now find the period of the function. Well, the period of the function is all about the matter of fact, the value of b. So the period, it's always what? 2 pi over b. Again, the given structure here, so this one is just the ultimate form. So 2 pi over b. So then that'll be 2 pi divided by 150 pi. So reduce it. So pi cancel. So 2 over 150. Then that'll be 1 over 75. Okay, so this one is just the period to value P. And now determine the maximum and the minimum blood pressure reading for this individual without using a calculator. Again, so this one, it shows the vertical translation. So this one is 20. So the max would be considered 20 plus 110, which is 130. And then for the min, then that would be considered negative 20 plus 110. So for that number, then that would be considered 90. Okay, so it's pretty straightforward. It's not that difficult. Okay, so now let's see what else that we got. Okay, so now the Ferris wheel problem. So let's start with number 9 here first. Okay, so number 9, a Ferris wheel of radius 30 feet passes 4 feet above ground. Okay, so let me just put it to the new slide first. Okay, let's put it right here. And if the wheel makes one complete revolution in 18 seconds, okay, so one complete revolution in 18 seconds. So 1 ReV for every 18 seconds. And the other thing that we noticed, the radius, 30 feet. And it's 4 feet above the ground. So, what equation describes the height of a person on the wheel as a function of time if the person begins the ride at the lowest point on the Ferris wheel? Okay, so now let's just illustrate the picture here. So the Ferris wheel. So we do know that's a circle. And this one, it's 4 feet off the ground. Okay, 4 feet off the ground. And we do know that the radius of this Ferris wheel is 30 feet. Okay, so 30. It's 30 feet, not off the ground, but it's off the position right here. And now, what else do we know? We do know that in order to complete one complete revolution, so that it takes, what, 18 seconds? So one thing that we want to find out is that the angular velocity. So we do know that one revolution for every 18 seconds. So we do know that one rev is considered 2 pi radian. Okay, so let's find out that omega, or W, angular velocity. So what we found here, so this one is considered 2 pi over 18. Cross cancel out the 2. 18 reduced down to 9. So this one basically just pi over 9 radian per second. And now, for those you might be wondering what that W stands for here, so you'll see that in a minute. So back to the equation, what we got before, the ultimate form. It's like y equals a cosine of b times x minus h plus k. Well, the thing is that if this one is the Ferris wheel, so that means there's no h, there's no horizontal phase shift here. So we started with the lowest position down the bottom here. So this one is the lowest position. Okay, so for that W, so W is just like B. Okay, so it's the angular velocity. So sometimes this one is written as A cosine of W x. Well, instead of using x, x is the time. Okay, so that's the variable in terms of the time. And then plus k. So what we found here, so W, which is what, pi over 9 times t cosine. And then A, for those you might be wondering what A is, So A, basically this one, it tells you about the radius of the Ferris wheel. So which is what, 30 feet? And then here's the matter of K. So now for K, so what happened, started at 0 in the initial distance. Well, the initial distance here is 4 feet off the ground. Okay? So we need to find out the distance from the center of the Ferris wheel all the way to the bottom to the ground. Okay? So the distance here, then that'll be 34. And also we need to convert this one to its negative. The reason why we want to convert that cosine to its negative, well, because that when t equals 0, well, this one would be considered negative 30. Okay, cosine of 0, that's 1. Okay, so 1 times negative 30, then that'd be negative 30. And then negative 30 plus 34, then that'd be 4 feet. So it's 4 feet off the ground for the initial amplitude. Okay, so then that'd be the equation of the Ferris wheel. Okay, so again, K, so that represents the distance from the center of the Ferris wheel to the ground. Okay, so that's how you come up with this function here. And now, let's see, what about for number 10? Number 10 is quite similar. Okay, let's see right here, number 10. So a person enters a Ferris wheel at the lowest height of 10 feet. Okay, so that means it's what, 10 feet off the ground? Okay, so we can always annotate. And the Ferris wheel travels clockwise and complete 1 revolution in 30 seconds. So clockwise. So that's why I put it as a negative. And the radius of the Ferris wheel is 40 feet. Okay, so radius 40 feet. 1 complete revolutions, 30 seconds. And find equations of motion, knowing that the person began to ride at the height of 10 feet. Okay? So find out that the functions with that initial position, 10 feet. And then what's the height of the person on the Ferris wheel at time t equals 8? So once we set up the equation, we can just plug in the time. If the person completes 6 revolutions on the Ferris wheel, what time does the person spend at or above 35 feet? Okay, that's an interesting one. And after the Ferris wheel has traveled in angles of 7 pi over 6 from the starting point, and what is the height of the person? Okay, that's another interesting one, so we're going to find out. Okay, so again, let me just snip this one. Okay, so all this, and then let's just take this one over here, active inspire. Okay, so here's what we got. 1 revolutions for every 30 seconds, so similar to the previous problem, like what we did for A. So step 1, find the angular velocity, W. So 1 rep over 30 seconds, multiplied by 2 pi radian over 1 rep. Again, cross cancel. So we got pi over 15 radian per second. Okay, so again, this one, it shows that it's the W. And now angular velocity. So once we find the angular velocity, so just plug in that. Let's find out K. So K, which is from the center, and then all the way to the ground. So the distance from the center of the Ferris wheel to the ground. So we do know that the lowest height is 10 feet. So we do know that the Ferris wheel is 10 feet off the ground, the lowest point. So this one is 10 plus the radius which is what, 40 feet. So it's 50. And then using the same kind of model, y equals negative cosine of negative a cosine of wt plus k. So then that would be considered negative 40. Cosine of pi over 15 t, and then plus 50. Plus 10. Oh, wait a minute. Plus k, then that would be plus 50. The distance from the center of the Ferris wheel all the way to the ground. So this one's for A. And now what about for B? So what's the height of the person on the Ferris wheel at time t equals 8? So basically plug in 8. Okay, so again, this number here is pi over 15. So plug in the times. So negative 40, cosine of pi over 15 times 8, and then plus 50. So this one you want to evaluate that on the calculator, because this one won't give you the exact number. Okay, so find out what that is. And then for C, so if the person completes 6 revolutions on the Ferris wheel, so what time does the person spend on above 35 feet? So spend at or above, okay? So that means, so for the equation would be considered negative 40, cosine of pi over 15, t, and then plus 50. So we want to set that greater than or equal to 35. And then basically from here, you just want to solve for t, okay? So negative 40, cosine of pi over 15t. It's greater than or equal to, so 35 minus 50, then that'll be negative 15. So this one is just finding that the time it takes for the first revolution. Okay, in order to complete 6 revolutions, so this one will be considered 2 pi 15t, and then 3 pi 15t, and then 4 pi 15t, and then 5 pi 15t, and then 6 pi 15 over 15t. Okay, so let's just find out the first revolution. Okay, so divide it. So this one we got cosine of pi over 15t, so which is greater than or equal to, well, if you divide it by negative 40, that means you need to switch the less than greater than. So this one turns out to be less than or equal to 15 over 40, then that'll be considered 3 over 8, and then this one just do it on the calculator and see what that is. So inverse of cosine of 3 over 8 in radian form, so then that'll be less than or equal to pi over 15 times t. Okay, so and then you solve for the time. So that's the first, the time interval that, you know, it takes for that, for the Ferris wheel going at or above 35 feet. And then the second revolution, similar. So it's negative 40. And then cosine of, well, this number right here, then that'll be what? 2 pi over 15 t. It's greater than or equal to negative 15. So basically just add that pi, add that, well, you need to add 2 pi. So if you add 2 pi, then this one would be considered not just 2 pi over 15. If you just add 2 pi, this one would be considered, okay, like this. So I just put in the multiples. So gotta be very careful with this type of problem. So if that's after one complete revolution, the other one would be considered pi over 15 t plus 2 pi. Okay, and then from there, you want to solve for t. Okay, let me just rewrite it. So pi over 16t plus 2 pi, and then it's greater than or equal to negative 15. Okay, everything else we don't change, so just the quantity right here. Because that it's after one complete revolution. So the second revolution, the third, the fourth, the fifth, and then so on and so forth. Okay. And now what about for D? After the wheel has transversed and angles of 7 pi over 6. So this one is one of the interesting one. So if the angle is being formed as 7 pi over 6. So again, t is the time. But this one, if you multiply by the time, after by pi over 15, you'll get the angle. Okay? So what you need to do, again, angular velocity times the time, what does that give you? The measure of the angle. So that means for part D, so it's negative 40, cosine of that angle, 7 pi over 6. Now 7 pi over 6, we're going by, okay, so the Ferris wheel. So here's what we consider pi. If that's 7 pi over 6, so that just barely passed that pi. Because once you go half of a Ferris wheel, then that would be considered what? Pi, 180 degree. So 7 pi over 6. Again, here's the starting point. And then 7 pi over 6 would be over here. Okay, so that angle. Okay, so using that, the model, so negative 40 cosine of 7 pi over 6. Okay, no need to worry about the time, because once you multiply with the time, it's always the angle. And then plus 50. So you'll find out what y is. So the position of the person on the right. Okay, so cosine of 7 pi over 6. What's cosine of 7 pi over 6? So that's just the multiples of pi over 6. Okay, so cosine of 7 pi over 6, that's going to quadrant 3. So negative, negative. So then that'd be positive. So cosine of pi over 6, cosine of 30, then that'd be 1/2. So this one's negative 1/2 times negative 40, then that'd be 20. So 20 plus 50. So the person is 70 feet high. Right over there. Okay, so that's it. And let's see what else. Number 10. And number 11, that one is quite similar, but this one it's like it's about the spring. So a spring holds a weight and it's allowed to bounce with a maximum of 12 centimeter above and below the equilibrium point. And the time for one complete cycle is 3 seconds. So again, this one shows that the revolutions per second. So one complete cycle in every 3 seconds. So write an equation that describes the motion of the weight. Assume that the weight it's the equilibrium when t equals 0. Equilibrium, that means it stopped moving, so it's like everything's bounced. It's being balanced. It's not moving. It's not like moving around. So what we got here, so 12, which is considered the value of A. And then again, this one, we can convert that to find out the angular velocity. So 3. So that's just the time. So it's one complete revolution for every 3 seconds. So 1 rev over 3 seconds. So multiply that by 2 pi over 1 rev. And then what we got here is 2 pi over 3. So the model here, so there's no any kind of like a vertical translation. So the model is just consider y equals so then that'll be considered A sine W times t. Then that'll be considered 12. So sine 2 pi over 3 times t. Just like that. So just like a basic form, there's no horizontal phase shift, there's no vertical translation. Okay, so that's it. So again, any questions that you have, make sure that you fast forward or just rewind back to the part of the word problem or the analysis that I put in here for the domain, range, all that. Okay, so thank you for watching it, and I'll see you guys next time. Take care.